Good day, I'm Fernando Manalo from ECA42, and today's experiment is for the Robotics Lab TECT415LA. And for today's experiment, the laboratory activity number 1, DC motor control with computer and microcontroller interfacing. The objectives of this experiment is to control the direction of a DC motor, to control the speed of a DC motor, and to create a program that user interface to send data to the Arduino. To start the experiment, here are what we need for the experiment. First, we need the Arduino Mega 2560 as our microcontroller, an L293D motor driver. In this case, I opted to use a motor shield, Adafruit motor shield driver version 1, which uses the L293D IC. I also need a 12 volt DC motor, 12 volt 1 ampere power supply, a screwdriver, and I don't need to use breadboards and connecting wires, as I will be using this Adafruit motor shield version 1 L293D motor driver. Before we proceed to the interfacing of the microcontroller to the computer to control the DC motor, let us first build our circuit assembly. And based on our circuit assembly, I will simply, as this is a motor shield, Arduino shield, I can simply connect this here. As you can see, it lines up with the pins of the Arduino. And we have to make sure the connection is stable. Now that I have connected the motor shield, I will connect this 12 volt DC motor to port M3. And then connect my 12 volt power supply to this adapter here. And then I will connect the Arduino to my computer. We also need a computer or laptop. This is the code for my direction control. And this is the code. I use 3 conditions for A, B, and C. A turns the motor clockwise, B turns the motor counterclockwise, and C stops the motor. And that is all using the serial monitor. And as you can see, I've already connected my circuit assembly to the power supply, and the LEDs are indicating that it is running correctly. Now I will upload the code. Now it is done uploading. We will go to the serial monitor. And as you can see, it is the DC motor control. If I send, as right now the motor is not running, if I send the character A and hit enter, the motor is turning clockwise. Now if I send a character B, the motor is turning counterclockwise. Now if I enter character C, it's capital C, and hit enter, the motor will stop. And to test it again, let us go to character B. And as you can see, the motor is turning counterclockwise. And with character A, the motor is turning clockwise. Sending a character C stops the motor. And now we have already we know that our code runs correctly and the circuit is working correctly. Now let us go to number 2, which is to create a program that will control the speed of the motor by controlling the pulse width of the microcontroller by sending 0 to 255. Sending 255 will cause the speed of the motor to the fastest. And this is my code for the DC speed control. And in this code, as I use the AF_DC motor library, in order to change the speed, simply use the motor.setSpeed. And using the serial.parseInt, we can get the integer in the serial monitor. And I also used a constraint command so that whenever the user enters a value larger than 255, 255 will be the maximum, as it is the maximum allowed for PWM. Now I will upload the code. We have an error. We haven't closed the serial monitor. Now we upload the code and it is done compiling. Now to start our code, we will go to the serial monitor, and as you can see, it is the DC motor speed control. First, let us I will enter 255, which is the fastest, and we will see the motor. Now it is turning the fastest. Now I will enter 10. Now enter. And as you can see, the motor slowed down when 10 is the value. If I enter 5, it will be even slower, as you can see. If I enter 100, the motor will be faster again. 200, the motor is even faster, and if we start at 50, 100, 150, 200, and 255. Now the motor is turning the fastest. And that concludes that our circuit and my code is working properly. And also, finally, to stop the motor, I will enter a value of 0. Now the motor speed is 0, and it stopped the motor. That's it. And that's the end of today's experiment. And as you can see, we have successfully connected our circuit, and our two programs for speed control and direction control of the DC motor is working properly. And that's the end of today's experiment, and thank you.